Hello everybody, welcome to this webinar. My name is Michael Wiendl, I'm an NC trainer at Heidenheim-Reuth in Germany, and today I want to explain the new touch probe cycles on the TNC 640. At first, I start with an overview and the possibilities of the new touch probe cycles. Then we take a look at the new parameters inside of these cycles and how to program these cycles. And at last, I prepared 3 examples, practical examples, how to use this cycle directly on the machine. Let's start with the overview. So we have 3 new cycles, the cycle 1410, 1411 and 1420. These are 3 new cycles for probing rotation. So we can use this cycle, for example the 1420, for an alignment of the surface and to transfer this alignment to the 3D basic rotation of the TNC 640. And we can use the 1410 and 1411 for the alignment of the coordinate system parallel to the workpiece surface. So a basic rotation or, for example, a table rotation. Also, we can use tolerances during the measurement, and we can also automatically interrupt the probing cycle to do a manual prepositioning. That's the semi-automatic probing inside of the cycles. So the new cycles have also new input possibilities in the parameters. So we can input an absolute coordinate, for example, when I know, because the probing cycles, they are automatic probing cycles, and for automatic probing cycles I should know the position of the workpiece in the machine room, and then I can just input the absolute values from my coordinate system, and then the probe goes automatically to this position and starts probing. A very important information in the new probing cycles is that all the input programmed coordinates are, for the control, the nominal coordinates. So the control already calculates with my input, and this input is then the nominal surface. So already an input for the control, and then we measure the surface, and then we get the actual surface, and then the control calculates the difference between the nominal surface and the actual surface, and the result will be then the angles for the aligned surface. I can also input a string parameter, so a text, and inside of the text I can program a question mark. Question mark says, I don't know where the position in the machine room is. So I know the position of the probing point from my drawing, but I don't know where the workpiece or where the probing surface in the machine is. So I want to use a manual preposition to bring the probe to the correct position and then start the probing with NC start. And that's the question mark. There I can activate the semi-automatic probing. I can also insert tolerances. So for example, when I make a measurement in the Z- direction, I can input a tolerance to the programmed point. So for example, the program dimension should be 0, and I program minus 0.2, minus 0.4. This is the dimension or the tolerance for my programmed 0. And then the control can check this tolerance inside of the cycle. And I can also use inside of the string parameter in the text field, I can input an at. And at, with at I tell the control, I know the nominal position and I know the actual position. And so the control should not do any probing, just calculation. And for that, I can use the at parameter. It is important that the definition of every point has the same symbol. So when I want to, in the first point, for example, when I say the first point with a question mark in the reference axis, then the minor axis and the tool axis also needs a question mark. So the point must always be programmed in the same way. So when I use a question mark, I have to program all the values from this point with a question mark. But only for the point. The second point can be different, but inside of the first point, x, y, and z must be always the same input. So question mark or absolute coordinates or the at possibility. That's very important. Of course, we measure the rotation of the workpiece, and this rotation we can, in the next step, align with our round axis, and therefore we can choose the stay, move, or turn possibility, so how the round axis should move. So stay, no movement, move, the round axis will do the movement, and the linear axis will always also do a movement, that the tool tip stays at the same position at the workpiece. And turn is just a movement around the mechanical turning point of the round axis and no movement of the linear axis. And we can also use the probing rotation cycles to set a datum in the probing direction. So for example, when I say I want to probe in the Z minus direction, then I can decide if I want to use my probed points 1, 2, or 3 for my new datum, or if I want to do the middle of the 3 points, then I choose 4. With 0, I don't want to set a datum, then I can do it afterwards with another cycle in the probing program. And I can also decide what to do with my probed angle. I can say I want to store it as a basic rotation or as a 3D basic rotation in the columns SPC, SPB, SPA of the preset table. Or I can decide that I want to use, for example, my C-axis of the table to compensate the angle. Then I choose 2 for table rotation. Of course, this depends on the machine. It could also be A or B, but always it must be the last round axis of the kinematic description. So the programming, we go to the hard key touch probe, then the soft key rotation, and on the first soft key row, there we have the new cycles 1420, 1410, and 1411. They are available on the TNC 640 since software 8. That was the first software where we installed these new cycles. And then we can program our coordinates and also the probing direction. So I can choose different probing directions in every cycle. And what's the different? The preset, the programmed preset there is no possibility to program a different preset. So we always write the values in the active preset. That's new. There is no preset line where I want to store the values. I always store it in the active preset line. And of course, the probing results will be stored in the parameter Q950 and higher. For this, you can take a look in the user manual. There are all parameters described, which result comes in which Q parameter. Let's take a look at the application examples. At first, a simple surface alignment. So we know the coordinates of the workpiece. You see it on the right side. The workpiece is clamped on the table. And now we want to align the surface to make a remilling of my workpiece again. It's important that the set coordinates, so because we probe in the Z minus direction, so the set coordinates must be all on the same position, so on the same height. For example, Z0, because as I mentioned before, we program here the nominal coordinates. So the control is already calculating with my programmed values, and otherwise I get a wrong result after the alignment. The same for the alignment of the coordinate system. Also here we program the Y coordinate. So we probe the front side of the workpiece. This is the x-axis, and the probing direction is the Y plus axis. So the Y coordinates must be on the same level. That's very important. So let's take a look at the example program. So here we see our two probing cycles, the 1420 and the 1410. You see in the 1420 the tool axis coordinate of the first point and the second point and the third point are the same. They are all on Z0 because the surface is a flat surface. There are no stairs on the surface. So the probing points must be the same. Of course, with this possibility, we can also use a surface where there are stairs on it. So the first probing point is at Z minus 10, the second is at Z0, and the third probing point is Z plus 10. Then the control calculates the differences between my nominal points and the actual points, and the difference will be the aligned surface. So input the 3 points, then decide the probing direction, the setup clearance, and the compensation. So we want to do the compensation in the preset table. So we want to use the 3D basic rotation. And we also, with the Q1126, we want to do alignment of the table. That the round axes are positioned, that the probe after the surface alignment is in rectangular to the to my surface. And then the same with the 1410 cycle. Also here, the Y coordinate of the second point and the first point is the same. That after the probing cycle, the new coordinate system x plus axis is parallel to my front side of the workpiece. And that's the really important thing, that we always take care about our programmed values, because these are the nominal values, so already the control is calculating with it. So let's go to the machine and start the program. So the first point, measurement in the Z minus direction, the second point, and the third point. And now the control just makes the movement that the probe is afterwards rectangular to the programmed surface, and afterwards the coordinate system is now aligned to this front surface here of my workpiece. So that is the task of these two cycles, and the values are transferred to the preset table, and there we use the 3D basic rotation, so the columns of the SPA, SPB and SPC, and then we can use this 3D basic rotation later on for our machining. The second application example is now the same as before, but now we don't know the coordinates of my workpiece. So I don't know the exact position of my workpiece. And because this is an automatic probing cycle, we normally should know the position plus minus 2 mm to find the workpiece for probing. But if I don't know the position, then I can also use the new probing cycles. Because then we use the question mark for the semi-automatic process. Also, we can do the same for the y-axis. And there you always see, be careful with the nominal coordinates what you program in the cycle. Inside of the cycle we see now that there are a lot of question marks in the cycle. So we define the first point with the question mark, the second point with question mark, and also the third point with a question mark. And so we have 3 points, the manual prepositioning possibility inside of the cycle. And also here, the tool axis of the first point, the second point, and the third point is on the same level. That's very important, that the control can calculate in the correct way. In the 1410 cycle, we see now also a possibility. So when we use the question mark, we only need to input a value in the probing direction. So you see the probing direction, the Q372 is +2, so the probing direction is Y+. So we only need to input a value in the minor axis, first point and second point, that the control can calculate. When I only program a question mark without any value, the control takes automatically the actual position as nominal position. And then we can calculate the correct angle, or prepared angle for my probing situation. So this is also a possibility that I only input a value in the probing direction, and the rest I just let empty without any entry, just a question mark in it. So you see, we started the cycle with NC start, and automatically the control stops, and now I'm in the manual preposition mode. So now I can use the axis key of the keyboard or the hand wheel to do the preposition, and when I'm on the correct position I say NC start, and the control will do the first measurement. Then I make the preposition to the next point to the second point, and NC start and go on to the third point. So for this, I don't need to know the position of the workpiece in the machine room. It's just to find the correct position manually by hand with the semi-automatic probing mode. And then for the 1410 cycle, for probing surface here, we just use the value in the minor axis that the control knows that the two probing points are on the same Y position, that we get the correct behavior of the x-axis after the alignment of the edge here. Also, the results again in the preset table. So there we have our aligned workpiece correctly set it in the preset table. And the last example, a very specific example, but also a good possibility to show you how the add function is working with our new probing cycles. So add says that I know the nominal position and I know the actual position. So these two values I know, and the probing cycle should just calculate for me. And that is an example what we often have in the mold and die production, that the workpieces are aligned over 3 balls which are clamped on the mold, and they know the nominal position from a special QS measurement machine, and directly on the CNC machine they probe the actual position. And with the nominal position of the ball and the actual position of the ball, we can just align the complete workpiece and already set a datum for this workpiece with our probing cycles. And the structure here, of course, this is a prepared parameter program, what we are using for this example. So we know the nominal position. The nominal position is in the Q54, 55, and 56. So these are the nominal positions. And we read out the actual position from the preset table. So we just set a preset for every ball in the middle of the ball in X, Y, and Z. And this position we read out with the Q51, 52, and 53. And then we make an QS parameter, a string parameter, where we use the values of the nominal position at the values of the actual position. And so we create 9 string parameters. For the first point, 3, for the second point, 3, and for the third point, 3. And these QS parameters are later on just the input for the cycle 1420. And when I use the add function, the control will not do any probing. It's just calculation. So we will not need any probing because all the necessary information are inside of the parameters, and the cycle only needs to calculate. And that was also a request from mold and die production, that we can handle such a mold with 3 balls to do the alignment over the 3 balls. And when we see now NC start, it's a stop. And when we press NC start again, then the round axes are just moving and the probe is now perpendicular to the surface, to the aligned surface. and the values are again transferred to the preset table. And that's the third example to explain how this add is working. Yeah, and that was all from my side to this webinar, to our new probing cycles. So if you are interested in the new probing cycles, just get in contact with us, with our colleagues from our subsidiaries all over the world. Ask after the new cycles and they can help you, and also help you directly at the control, or just send us an email or phone us. Thank you for attention and see you next time. Bye bye.